In a plane, the set of all points the same distance from a given point is a circle. The given point is the center of the circle. The center of the circle is not part of the circle, but it is very important to the circle. In this circle, the center is labeled A, and the circle is called circle A, and we often use the symbol, which is a very small circle with a dot in the middle, as shown in the lower right. The distance around a circle is called the circumference. A segment from the center of a circle to any point on the circle is a radius. A segment that has both endpoints on a circle is called a chord. A chord that passes through the center of a circle is a diameter. The ratio of the circumference to the diameter of every circle is the same. And you may already know that that ratio is called pi. It is an infinite non-repeating decimal. An approximation often used for pi is 3.14. I've used a piece of software called the Geometer Sketchpad to measure the circumference and the diameter of 3 different circles and then divided the circumference divided by the diameter in each case. And in our first example, you can see the circumference is between 23 and 24 centimeters, and the diameter is about 7.5 centimeters. And we had the software divide the two numbers and round to the nearest hundredth, and you can see the answer is 3.14. Here's another example. The diameter is a little larger, and you can see the circumference is a little larger, but the circumference divided by the diameter is still 3.14. And in our final example, the circle is the smallest of the three. Circumference is just over 16 centimeters, and the diameter is just over 5 centimeters. The circumference divided by the diameter, once again, rounded to the nearest hundredth, is 3.14. You may have noticed that a diameter is a pair of radii extending in opposite directions from the center of a circle. And you may have also noticed that 2 times the length of a radius is equal to the length of a diameter. Well, that leads us to some formulas. We start with that pi is equal to the circumference divided by the diameter of any circle. And if that equation is true, then it's also true that pi times the diameter is equal to the circumference. And since 2 radii is equal to a diameter, we can substitute and say pi times 2r is equal to the circumference. But that's more commonly written using the commutative property as 2 times pi times r, or if you say it quickly, 2 pi r is equal to the circumference. Well, both of the two circled formulas are considered acceptable formulas to find the circumference of a circle. The top one, pi times the diameter, and the one at the bottom, 2 pi r. The space inside a circle is the circle's area. Now let's take a circle and let's see if we can figure out how to get the formula for the area of a circle. Well, we're going to take this circle, and again, using our software, the Geometer Sketchpad, we're going to divide it into 72 equal pieces. And then we're going to lift those pieces out a few at a time. We started with 1. We removed the one that's now left red, put it down there near the bottom. And then we removed another one, and notice how we laid it down in the opposite direction. And then we removed 2 more. Now we have 4 removed from the circle. Now we remove 4 more, so now we have a total of 8 at the bottom. And then 8 more. Then 16 more. And then 32 more, but remember there were only 72 in the first place, so there's only 8 left, so we're going to remove them and alternate them like we've done with all the rest. And now all of the little pieces of the circle have been removed and rearranged, and you can see it looks somewhat like a rectangle. Not exactly a rectangle, but very close. And if we think of it as a rectangle, because of the way we removed the pieces, I hope you can all see that the width of this rectangle is the same as the radius, so we'll label that r. Now the length of the rectangle is a little bit trickier, but I hope you can see that the length of the rectangle has to do with the circumference, because that's the other side of each piece of the circle. But because we alternated the pieces, half of the circumference is on the top and the other half of the circumference is on the bottom. So that means the length of this near rectangle is half of the circumference. So we use the formula 2 pi r, and then we divide it by 2 because it's half. Well, now we have the fraction. You can see it at the bottom, 2 pi r over 2. Well, 2 over 2 is equal to 1, so we can cancel those 2's. And now we know that the width of the rectangle is r, and the length of the rectangle is pi times r. And then we multiply the length times the width to get the area of the rectangle. And of course, r times pi times r can be rewritten as pi r squared, a formula you may already be familiar with. And of course, that's the same as the area of the circle because the rectangle consisted of removing all of the pieces of the circle. So every part of the circle is now part of the rectangle. Now again, I said it was a near rectangle, but imagine instead of 72 pieces, we could cut this circle into infinite pieces. Then it would be a rectangle, and that's why the area of a circle is pi r squared. Well, let's do some examples. We're given a picture. Find the area and the circumference of this circle. We examine our picture and we see that we're given a radius. So r is equal to 3. And then we plug that 3 into our formula 2 pi r to get the circumference. So that's 2 times 3.14 times 3 centimeters. We're going to use 3.14 as an approximation for pi. And we multiply that out, and our circumference to the nearest hundredth is 18.84 centimeters. Now another way to write the circumference is to write it in terms of pi. So we start with the same formula. We plug the 3 in for r, but we leave pi as the symbol pi. So then all we need to do is 2 times 3 and attach pi. So in terms of pi, the circumference of this circle is 6 pi centimeters. We say that 6 pi centimeters is an exact answer for the circumference of the circle, and the 18.84 centimeters is rounded to the nearest hundredth. Well, now let's use the area formula to find the area. Once again, the formula is pi r squared. R is 3. And then when we multiply 3.14 times 3 centimeters, we get 28.26 square centimeters. And in terms of pi, we have pi times 3 centimeters, or 9 pi square centimeters, the area of this circle. And another example, in this picture, we still have a 3, but the 3 is the diameter. So we need to do a quick calculation, and that means the radius is 1.5, and our unit in this problem is inches. So we're going to plug 1.5 into our formula, 2 times pi times 1.5. And then we do the arithmetic with a calculator, and our circumference is 9.42 inches. In terms of pi, we simply do 2 times pi times the 1.5 inches, and we leave the pi alone. 2 times 1.5 is 3. So in terms of pi, this circumference is 3 pi inches. And now using the formula for area, we'll find the area. R is 1.5, so we have 3.14 times 1.5 inches times another 1.5 inches. We get out a calculator, we do the arithmetic, and we get 7.065 square inches as an approximation for the area of this circle. And if we want to write it in terms of pi, we have pi times 1.5 inches times 1.5 inches, which comes out to be 2.25 pi square inches. Here's a problem that doesn't even have a picture. We're just given that the circumference of a circle is 12.5 meters. And our job is to find the radius, the diameter, and the area of this circle. And we're going to round it to the nearest tenth. So the circumference divided by pi is equal to the diameter. So we'll plug that in, and we'll use 3.14 for pi. And when we do that, we get 3.98 meters. We're going to leave it to the nearest hundredth now and round off at the very end to the nearest tenth. And by using 3.98 in subsequent calculations, we should eliminate something known as round-off error. Well, now to get the radius, we do the diameter divided by 2. So we plug in the 3.98 divided by 2, and our radius is 1.99 meters. And to get the area, it's pi r squared. And r is 1.99 meters. We do the arithmetic with a calculator, and our area is 12.43 meters squared. Now we'll round everything off to the nearest tenth. Our diameter is about 4 meters, our radius about 2 meters, and our area about 12.4 square meters. Here's one final problem. The curved part of the figure at left is a semicircle with a diameter of 10 centimeters. We're going to find the area and the perimeter of this figure, and we're going to use 3.14 as an approximation for pi. Well, we're going to do the area first this time. We have to look at the 10 centimeters, and in our head we can quickly say the radius has to be 5. So it's pi r squared, but since there's just a half a circle, we're going to divide it by 2. Well, r squared is 25. So we get pi times 25 over 2, and we let the calculator do the work, and we end up with 39.25 square centimeters as an approximation for the area of this figure. And now for the perimeter. Notice we call it the perimeter. The distance around a complete circle is the circumference. But in this figure, it's a semicircle, and then we go back across the diameter to get back where we started. So we call the distance around this entire figure the perimeter. Well, the circumference of the circle is 2 pi r, but since it's a semicircle, we then divide that by 2, and then, of course, we add the 10 so we can get back to where we started. And we plug in 3.14 for pi, multiply it by 2r. Remember that r is 5, so 2r is 10. 3.14 times 10 is 31.4. Divide it by 2, and then add 10, and our final answer for the perimeter is 25.7 centimeters. The set of points in a plane the same distance from a given point is a circle. A segment from the center of the circle to a point on a circle is a radius. A segment with endpoints on a circle that passes through the center is a diameter. The ratio of the circumference over the diameter of any circle is pi, and the circumference of a circle is pi times the diameter, or 2 times pi times the radius. The area of a circle is pi r squared.